Hey everyone, welcome back to my vlog. So today we have something special in store. So we'll be diving into a piece of a Java code to understand how it works. So the code we'll be exploring is an implementation of a stack data structure using a linked list in Java. But before we dive into the code, let's take a moment to define what a stack is. So a stack is a data structure that follows the last in, first out principle. So this means that the last item added to a stack is the first one to be removed. Think of it like a set of plates. The last plate you put on top is the first one you'll take off. So here we have the first line in our code, which starts the definition of a Java class named stack as linked list. And after that is a line that declares a member variable root of the type stack node. And this will be the reference to the top element of the stack. And after that is a line that defines a nested class named stack node, which represents individual elements or nodes in the stack. Inside is a declaration of an integer variable, which is data. So this will be used to store the value of a stack element. And after that is a declaration of a reference variable, which is named next. So this will be used to point out to the next element in our stack. And after that is a constructor for stack node that initializes a new node with the provided data value. So here in our code, we have several methods. We have our isEmpty method, the push method, we also have pop method, peek method, and here we have our main method. So here we have the entry point of our program, which is our main method. So inside our main method, we have this line here, which creates an instance of a stack as a linked list class named SLL. So this instance represents the stack. It then proceeds on to call the push method in these three lines here. In the first line, we have the data, which is 10. So let's try to take note of it, and then let's go into our push method. So here we have our push method. So the push method adds an element to the stack. This line creates a new stack node with the provided data value and assigns it to the new node variable. It's a new stack node with the provided data value. So our first data will be 10, so it will be used here. And then it assigns it to the new node variable. We have an if statement here. So this checks if the stack is empty or the root is null. So since the stack is still empty, this statement is true, the root is set to the new node, making it the top element. So our data, which is 10, will be our top element now. So using the system out print, it then prints out the data with a corresponding statement pushed to the stack. So as we can see in our output here, we have this first line, so 10 pushed to stack. So as we can recall, our first data is 10, so it is now being pushed onto our stack. Back to our main method, we have the data, which is 20. So we go back to our push method, and just like the first one, we try to remember our data. So in this case, our data is 20. Our value, which is 20, is used. Again, we check if the stack is empty. So since our stack now is not empty because we have the value which is 10 there already, so we proceed to our else block of code. So if the stack is not empty, it does something different. So here inside our else block of code, we have this line which creates a temporary node, which is temp, to hold the current top element. So our current top element is our 10. So in here, we have this line which updates the root to the new node, making it the new top element. So our new node is 20 now. So after that is a line that sets our reference variable next of the new node to the previous top element, which is our 10. So this then effectively links the new node as our new top. So our new node, which contains the value which is 20, will be our new top. And after that, again, it prints out a message indicating that the data, which is 20, is pushed onto the stack as it is visible here in our output. So 20 pushed to stack is now printed out. So going back to our main method, we have to push the data, which is 30 as well. So again, using the push method, we create a new node with the provided data, which is 30, and assigns it as our new node variable. So since the stock is not empty, we proceed on to our else block of code here. So again, we create a temporary node, which is temp, to hold the current top element. So our current top element is 20. Again, we need to update the root as our new node. So our new node in this instance is 30 now. So the 30 would become our new top element. And after that is the setting of the reference variable next. So we point out onto the previous top element, which is our temp, in this case 20. And this action effectively links the new node as the top. So it then again prints out the message indicating that the data, which is 30, was pushed to the stack, as you can see in the third line of our output here. So going back to our main method, after all the pushing of elements into the stack, we have this line here which calls the pop method. So pop method removes and returns the top element from the stack. So inside our pop method, we have this line here which initializes an integer variable which is popped with the minimum possible integer value. So this value will be used to store the pop element. After that is an if statement which checks if the stack is empty, examining whether the root is null. So if the stack is empty, it prints a message which indicates that the stack is empty. But since our stack now is not empty because we have pushed data into it, we execute this else like here. So inside our else block of code, we have this line which retrieves the data of the top element and assigns it to the pop variable. So since, as we can recall, our top element is 30, so the value which is 30 will be assigned to the popped variable. After that is a line that updates the root to point to the next element in the stack. This effectively removes the top element. So it removes the data, which is 30. And after that, it returns the value stored in our popped variable. So going back to our main method here, since we have the value of our pop element, it then will be printed out with the message indicating that it is popped from the stack. The fourth line of our output, we have our element, which is 30, with the corresponding message popped from the stack. So our data, which is 30, was popped from the stack. It is removed from the stack. Next, we have this line here. So it calls our peak method. So let's take a look at our peak method. So here we have our peak method, which returns the value of the top element, this time without removing it. So here, inside our peak method, we have an if statement which checks if the stack is empty by examining whether the root is null. But since our stack still has values in it, such as the 10 and the 20, so we proceed on executing the else block of code here. So inside, we have this line which returns the value of the data in the top element of the stack. As we can recall from our previous execution, we have successfully removed the value which is 30 from our stack, so making that 20 as our new top element. So in here, 20 is our top element now. So it returns the value of the data of our top element. So going back to our main, we have a corresponding message here, which is top element is, and then the value retrieved from our peak method, which is 20. So our output here indicates that the top element is 20. After that is a line that prints a message indicating that the following output will display the elements in the stack. So we have a while loop here, which continues as long as the stack is not empty. So it checks using the is empty method. So this method will check if the stack is empty. So it begins an if statement, checking if the root is null, so indicating an empty stack. So since, as you can recall, we still have values 20 and 10 in our stack, so we proceed on to executing the else. If the stack is not empty, it returns false to indicate that the stack is not empty. So going back in our main method, inside we have the system out print, which uses the pop method to print out here we initialize the integer value, which is popped with the minimum possible integer value. After that, we have an if statement, which then checks if the stack is empty by examining whether the root is null. So since our root is not null, so we proceed on to our else here. So inside our else, we retrieve the data from our top element, which is 20, and assigns it to the pop variable. And again, we update the root to point out to the next element in the stack. So the value stored in the pop variable will be returned. In this case, we have value which is 20. So going back to our main method, it will print out the value which is 20. So as you can see in our output, we have the value 20 in here. So elements present in stack, we have the value 20 in here. Going back to our loop, again using the isEmpty method, we check if the stack is empty or not. So in here, since we still have value in the stack, so it will return false. So going back to our main method, printing out the element, of course using the pop method, same as the previous ones we have done, will be executed as well. So the value, which is 10, as you can see in our output, is printed, same as the first ones we have. So within our loop, it uses the pop method to remove and print elements from the stack one by one, separated by spaces. Since the values of our stack, which is 20 and 10, is being popped, and since we no longer have values in our stack, so it terminates the loop and ends our program. That marks the end of the